So okay, with these two equations, I can relate masses from the sun, for example, to the things here like angular velocity and the radius. But in order to answer this question about how long is about time taken. So I need to know the time taken for the Earth to go around once. Now the time doesn't appear here, but directly, but we know that it can be related to the velocity, either angular velocity or this linear velocity. So what I'm going to do is this. I'm going to try and write down an expression relating the angular velocity and the time as well. That should be helpful for what we want to do. So the angular velocity is equal to if Earth rotates by an angle of, let's say, theta in a certain time t, then angular velocity is the angle in radians divided by the time. Okay. And we're interested in the time it takes for the Earth to go around the Sun, which is one full circle. So let's say that time is t. I'm going to let that time be t. We also call this the period of revolution of the Earth. Okay. So this period, in the time it takes for the Earth to go around the Sun in this period t, the angle would be 2 pi. 2 pi is the same as 360 degrees. So 2 pi radians. So this is another way I can write the angular velocity in terms of the period of revolution. Okay, so let me write down the name for this time. It's called the period of revolution. Okay. Right. So now we should have enough equations to relate the things everything that we need to find. Okay. So let me now try to combine this equation to obtain some formula to relate to obtain a formula for this time. Okay. Now the usual place to start is to look at the two forces and say, right, the centripetal force must come from the gravitational force in this case. So therefore I can equate those two. Okay, so I can say that the gravitational force gives the centripetal force. Right, it's the only force around, and so it must give the whole of the centripetal force. So here we are. We have this equation now. Now the first thing we notice about this equation is that the mass of the Earth appears on both sides, which means I can divide it away from both sides. So that's really convenient. It means that I may not actually need to know the mass of the Earth. But let's press on and see what happens. And with omega squared, I want to remember that I want to find this big T eventually. So I really like to express some parts of this in terms of the big T. And I can do it now. I can substitute 2 pi over big T for omega in this equation. So 2 pi over big T for omega here squared. Alright. That's R and that's G M over R squared. Okay, now let me try and solve for the period, the t. So I can bring the t squared over to the left, and then on the right side, what I can do is I'll simplify that. So the 2 pi squared, square of 2 pi will be 4 pi squared. R squared I can bring over to here, gives r cubed. Okay, and gm I can divide both sides by g and big M, so that brings gm over to this side. So now I have a formula actually for t. I have a formula for t. Now, if I can find r, g, and m, I should then be able to calculate this and take the square root and get t. So let me write down what I found from Google and Wikipedia. Okay, not that I'm advertising for them, but I'm just going to write down the numbers that I need. Okay, let me write it down. Sit down here. G G is 6.67 times 10 to the minus 4 in SI units. Mass of the sun. Okay, here we are. Mass of the sun right, that's 1.99 times 10 to the power of 30 kilogram. So that is very massive. That is hugely massive. And the distance of Earth from the sun, R. So look at that. That is right. Let me try and write this. That is 150 million. So that's 1, 2, 3, 4, 5, 6 zeros kilometer. It's that far away. That's a very large distance away. Okay, now the important thing now is that I have all the numbers. I have all the numbers here, and I can substitute them into this equation, and I can use my calculator and find the answer for this, and then take the square root to get t. So I've done that, and this is my answer. My answer is 3.17 times 10 to the power of 7 seconds. Okay, that is a lot of seconds. Now we know we want to compare with what we already know is the answer, right? We know that it takes exactly 1 year for the Earth to go around the Sun. So how many years are there in this number of seconds? How am I going to convert this? Right, let me try. So in order to convert this to seconds to year, this is what I need to do. First, I need to divide this by 60 to get minutes. Okay, I need to divide this by, for minutes I need to divide this by 60 to get hours, and then I need to divide this by 24 to get days. Right? And now I'm going to divide by 365 to get years. And I've done that, and my answer is 1.00 year. Exactly what we expected.